All right, so let's take a look at this spreadsheet. In the spreadsheet, we are going to basically randomly generate genotypes for a population of 50 people, and then take two people, make them together, and see what genotypes are present in the offspring based on the genotype frequencies. So how common is it to inherit recessive traits, or how common is it to be heterozygous for a certain gene or homozygous dominant for a certain gene. So that's what we are going to do here. So first off, we have this table that will give us the genotype frequencies. So in this case, we are saying that the frequency of the recessive trait, basically having two recessive alleles, little a, the frequency of this is 10% or 0.1 or 10%. So if that is the frequency of this recessive trait, then mathematically this will be the genotype frequencies for the other types of genotypes here. So you don't have to worry too much about how this was calculated, but basically this will already be filled out in your spreadsheet. But we just want 10%, 43%, and 47%. So one thing to note, so this is a homozygous recessive genotype here. The big A, little a is a heterozygous genotype, and big A is homozygous dominant. So this quotation mark is used so that Excel will distinguish between capital letters and lowercase letters. Otherwise, Excel will treat a capital A and a lowercase a as the same thing, and we don't want that to happen. So that's why it looks this way. So another thing to note, the cumulative column here ensures that randomly generated numbers will be generated according to the allele frequencies that we want, these frequencies that we have specified in column D. So the number of people that have certain genotypes will be randomly generated, and 10% of this population should have the homozygous recessive genotype. We want 43% of the population to have this heterozygous genotype and 47% to have the homozygous dominant genotype. So that's what this table or this column is for. So yeah, that's how I have generated this data here. We also have this table over here. So this table has all of the possible genotypes for offspring of two parents. So for instance, if we have two parents, one parent is homozygous dominant and the other parent is homozygous dominant, what are the possible offspring going to look like? Well, they both have the same genotype, so all of the offspring possibilities would be homozygous dominant. But if you have maybe a homozygous dominant parent and a heterozygous parent, what possible genotypes could there be? You could have offspring that are homozygous dominant or offspring that are heterozygous, and so on and so forth. So we have this table out, listed out here so that Excel can read the table and randomly pick one of the offspring possibilities. So we want to fill out our table and we want 50 individuals listed here. So we're going to start at 1, stop at 50, and make sure columns and linear is selected. You could also just basically type in a 1 and a 2 and just click and drag down and get to 50. That works as well. But anyway, we have 1 through 50 here. Now we need to put in a formula so that we can randomly generate genotypes. So we are going to put a VLOOKUP function in, and then we also want to use a rand function. So this generates a random number between 0 and 1, and the VLOOKUP function will basically read this table here and determine where the random number fits in and read out which genotype it would fit in. So we want to select basically B2 through B4 or C4 and press F4 to put $signs in there. And we want Excel to interpret the second column, or to read out the second column. And we want this to be an approximate match. So an exact match would mean that only 0.1 would equal the genotype AA, and nothing else would be coded that way. You would just get errors for anything else. So we want Excel to round the numbers just to fit in these percentages. So that's what we are going to do, and then press enter. And you can see that a genotype was randomly created here. So since there are random number generators used here, the numbers will keep changing as you do things in your spreadsheet. Don't worry about that. That's normal with random number generators. So below we have this table here, and we're going to basically calculate how many out of the population of 50 have these genotypes. So I'm going to use a COUNTIF function. And COUNTIF functions count each time a criterion is met. We want to count basically B7 through B56. So all of these 50 individuals here. And we're going to put a $sign just in front of A58. Take that and divide by count A. So count A functions count all the cells in the range that aren't empty. So we want to count how many cells have the genotype little a, how many have the heterozygous genotype, and how many have a big A, and divide by the total number of individuals. So then we'll put a $sign B7 through B56 again. And basically 4% of this population have this genotype. So technically you could just divide by 50, like count how many have a certain genotype and divide by 50, but we want to be able to use the same function consistently because we can't necessarily do that if we have blank cells. So then we can just click and drag, and Excel should adjust accordingly. So we have the $signs where we don't want the column to change, so that's locked in. But we are interpreting these genotypes, so we are allowing for Excel to go down in the spreadsheet. So the first genotype, little a, is cell A58, so that's fine. For this one, it's looking at what it should read here. So that's cell A59, that's cell A60. So just to make sure everything looks good, and these are our genotype frequencies here. So now we want to take some people from this population and breed them together. So we are going to use an index function. So an index function will read the population list and give us the data in the cell that we specify. And the cell we specify will be randomly determined, basically a number between 1 and 50. So we want to select B7 through B56 again. And we'll put in a rand between function. So we want to randomly pick a number between 1 and 50. So basically, we're just selecting a person at random. Excel is reading the genotypes here and just picking a random person between individual 1 and individual 50. And we can just copy this formula and everything should work here. So we want to count the genotype frequencies again, like we did earlier, but just with this population of 20 people here. So we're going to use basically the same formulas, but just adjust them to look at this table instead. So we'll use COUNTIF, and we want to select basically this table here. We want to read cell D18, divide by count A, and close the parentheses. And yeah, I should go D18, D19, D20. So now we need to have these partners breed together to create offspring. So we're going to be referencing this offspring table now. So this is a long formula that we're going to use here. We're going to use an if function and then rand between. So we want to randomly pick a number between 0 and 6. And basically put in greater than column A1, put in a VLOOKUP, D7 and E7. And then we are going to reference this table here, M2 to Q10. Put another rand between function between 2 and 5, and 0. And then a comma and 2 quotations. Okay, so what we are doing here, we're randomly mating the two partners together. And the VLOOKUP function that we have here will read the combination of the two partners. So basically, it'll look at cell D7 and E7, so these two partners here, look at that combination of the genotypes, find which combination it is, and then randomly pick a column 2 through 5, basically the offspring genotypes. And not all of them are going to necessarily always have offspring. There are some cells that will be left blank. So that's what these double quotation marks are going to be for. So the column function is basically referring to the column number in the offspring table, and a random number is generated between 1 and 6. So if the number that's generated is greater than the column number, then a child will be born. If not, the there will not be a child born. So it's just kind of randomly determining if they have offspring or not. So, for instance, some of these cells are left blank here, as you can see. So this couple has 2 offspring. One is heterozygous, one is homozygous dominant. This couple here only has 1 offspring. So you can evaluate the formula just to kind of see how it has been evaluated. So we have that random number between 0 and 6. And if it's greater than the column number, so we randomly generated 6, for instance, if that's greater than the column number, so the column number is 1 that was generated, then there would be offspring. So that's true. But keep in mind that since random number generators are being used, this will keep changing throughout your spreadsheet. So we will do the same thing and determine the genotype frequencies of the offspring. Once again, we'll use count if. We will select this whole table here and select G18 divided by count A. Select this table. G18, G19, G20. So that's it.